All right, our next topic in this unit is all about database design. This could be a review for some of you if you've done Biz 145 and you remember it, of course, but for others it'll be brand new. So let's have a look. I'm going to go through for you and cover the database design process, talk about entities and relationships and how that works and clarify that for you. We'll learn how to draw an ERD, that stands for Entity Relationship Diagram, a table map, an expanded version of that essentially, and then data dictionaries, one for each table, which again expand out the tables and tell you what's in there. All right, and then we'll look at some tips and techniques and processes we can follow for creating a good design. All right, so that's what we ultimately want, is a good database design. Now, just to remind you, in our last video we talked about what's a database all about. Well, it keeps track of things. Now we can use a spreadsheet to keep track of simple things like student grades, but if we want to, go beyond that and deal with multiple courses and multiple instructors and all that sort of thing, then maybe we're better to move into something like a database because that works really well at keeping track of multiple things, right? So we got multiple things on the go. We call these things entities, the things that we're keeping track of. That's our proper name for them. So if we're getting into a situation where there's lots of different things to keep track of, we're probably looking at a database. So what are the components of a database? Well, we have our tables, right? We've got our relationships between those tables, and then we have metadata, which is data about our data, helps describe what we're keeping track of in more detail. Those three things we decided were what's in a database. All right, so that's what a database is comprised of. So when we get into design, we're going to have a way of building these tables and describing them. We're going to have to describe the relationships, and we can use metadata to help ensure data integrity and all that kind of good stuff as we go. All right, so that's what we're going to focus on. Now, before you build any database, you want to start with a good design, right? It's like building a house. If you don't have a set of blueprints and you just start hammering boards together, you could end up with something like this. If you're lucky, right? It's probably a lot worse. Well, a good design for your database is going to help avoid future problems. It's going to make sure that the database works as well as intended. And it's really important. When I used to work in database design, I owned a company that did that for some time. We would often get called by organizations that would say, we'd like you to have a look at our database. And we'd go out and visit them and have a look. And they would say, can you fix our database? And I would say, yes, we can. I can fix your existing database for $10,000, or I can build you a new one for $5,000. And the reason it was cheaper to build a new one is because we wouldn't have to deal with the mess of the existing one. Often they were built in a way that wouldn't allow us to expand them or to add new features very easily. And so by going back to the beginning instead and doing it properly, we could do it cheaper. All right, so keep that in mind. You want a good design. And that's all we're really going to do for this part of our course. We're going to design it. We're not actually going to build any databases in Biz 241, but we are going to have a look at the design. So what's our process? Well, we're going to start here over on the left by coming up with the forms and the reports and the queries that the users might want. So we could ask them, what are you expecting to put into this database? What do you want to get out of it? How are you going to work with it? That sort of thing. That'll give us something we call the requirements. Right? So that's the requirements coming out of that. From those requirements, we can create our initial data model, which has got the entities and the relationships in it and all that sort of thing. May look like that a little bit, some lines between it. There we go. Got a little data model coming out of things. And so now we've got our data model, so that's great. Then we're going to go and take that a step further and work on our database design. So we'll actually specify in more depth what's in those different tables. Right? So let's take that and say what's inside those. That'll give us our tables. We'll identify what the foreign keys are that'll help us with those relationships and things like that. Coming out of that, we're going to have our database design. Once I've got to that point, right? Once I've got to that point, I can then just hand over that design document to a programmer, and ideally, they won't have to call me or talk to me anymore. They can just take a good design and create a database from it. All right. If they have to keep asking me questions, it means my design wasn't very well thought out and there are some missing pieces. So we want to create a good design that's well thought out and clear, and we can hand that over to the people who create the database and they take over from there. So in Biz 241, we're going to focus on this piece here. All right. Now, if you want in your own time, you're more than welcome to play around with Access. If you're curious and try to create a database too, that's just fine. But for our purposes, we're interested in the sort of the management piece up front. Okay, so that's what we're going to do. So databases themselves have to keep all the data necessary for other people to do their jobs. But we want to also keep in mind we only want that amount of data, no more, because it's costly to store extra data that you don't need, and you have to maintain that. So we don't want to do that. For example, when we keep data on students, we don't keep your height or your eye color or your hair color. That's not data that we need. It'd be just a waste of time and space to try to keep that and maintain that. What if someone changed their hair color? So, you know, it would be a total extra expense we didn't need. So we don't want to do that. All right. So, but we do want to make sure we have all the data that we do need that's necessary. So I can't forget to store phone numbers in the student database because I'm going to need that to do my job. All right. Now the users have a big role to play in all of this. Right? We use the word users to talk about the people who end up using the database in the end. They can tell us what to include. They can go and check our data model to see if it makes any sense and help us verify that things are correct and complete, all that good stuff, because we want to do that. So users are a very important part of database design. All right, so they're key to the whole thing. I mentioned entities, right? And I'll tell you a little bit more about those real quick. Those are the things that we're trying to track. So maybe orders for our products or customers, maybe the sales staff, maybe the individual items that were ordered. Maybe at Camosun we track students and we track fee payments. We track instructors. We track courses. Those are all things that we want to track. Sometimes they're actual physical things, like a product is, a physical thing, or a student is a, tangible thing, a person. Other times they're just logical. So an order, for example, or a grade, it's an idea. It's not actually a physical thing. And that's okay. We track both, right? We call those things entities. Now, when we write them, you'll notice in all the examples here, I don't say orders. I just say order. So we write in the singular, right? Okay, so we have the order table, not the orders table. Within each of those tables are entities, right? So those are the tables or entities we have. We have things called attributes. That describes the entity. Well, those are really our fields, okay? So that's another word for attribute fields. For example, some of the attributes of a student would be their first name and their last name, their student number, their address, their telephone number. Those are all attributes or things that describe you, okay? Key characteristics about you. One of those attributes or one of those fields will be unique. In the case of students, it's student number. Maybe in the case of employees, it's social insurance number in some companies. All right. Those are the key identifiers that no one else will have the same. Because there could be lots of instructors named Rob, for example, like me, but there will only be one instructor with my employee number. All right. So the key identifier for students, a good one is student number. Would telephone number be a good key identifier? Not really, because students often change their phone numbers and that phone number may get reassigned down the road. So that wouldn't work so well, would it? Whereas the college can guarantee that it never reuses your student number. We'll just keep adding more as we go. I still have my student number from when I was a student many years ago, at UVic, and it still works, and it's still there, and it'll never change. All right, so uh, that's the kind of thing we want for a primary key. Let's look at relationships. Entities are related to one another. Okay, they may be related in a few different ways. A one-to-one, a one-to-many, a many-to-one, or a many-to-many. Sometimes people use the little infinity symbol for many. Other times they'll use a kind of a crow's foot like that to represent the many. You could just use the letter M. That's a lot easier to type and things, so we'll use an M for our course. Let's look at an example. Each instructor can teach many courses, but each course only has one instructor. So if I have these two entities, here's my first entity, instructor. Here's my second one, course. Within instructor, I've got a list of all the instructors. Within course, I have a list of all the courses. One instructor can have multiple courses. That's what I've just drawn in red. Let's go in blue and go the other way. Each course only has one instructor. All right, so as I travel between them, I put the kind of number of the relationship on the tail end. All right, so each course only has one instructor. Each instructor can have many courses. That line in between with the 1 and the M on it, that's called the relationship. It's really a cross-reference, isn't it? We're going to use so I can connect my instructors and my courses to each other. All right, so that's a relationship. Let's have a look at Rob's wine cellar. I want to create a little database to keep track of my wine and where it came from. Now, if it doesn't matter if it's a friend or a store, I'll call that supplier, right? Just to keep it simple. What would the main entities be and how are they related? What do you think? Hit pause for a second and take out a piece of paper and see if you can come up with the main entities. And if you can, see if you can draw out the relationship too. And when you're ready, hit play and then come back to me and we'll see how you did. Okay, well, we're back. Let's have a look. I want to keep track of my wine. So I suppose I'm going to have a wine entity. I'll draw a box around that. So when we draw an entity, we put the name in the middle and we put a rectangle around it. Okay. I also have a supplier where the wine came from. And I think that's the only two, isn't it? I'm going to keep track of my wine and where it came from. So this is a very simple database, but that's okay for an example. So I've got those two. How are they related? Is there a relationship between the two? Well, there is. Wine comes from suppliers, doesn't it? Or suppliers give us wine. Now, each supplier could give me multiple bottles, couldn't they? So if I put my brother in as a supplier, he can give me many bottles over time. And many of my wine bottles could have come from him. Or many of my wine bottles could have come from the same store in town. So that's just fine. Each individual bottle of wine, though, could only have come from one place. So if I pull a bottle of wine out and I say, where'd I get that? Well, it could only come from one place. A bottle can't come from two places. Now, remember, these are individual bottles of wine in my wine table, not just types of wine. All right, so each individual bottle can only come from one supplier. Okay. Boy, if you did this and you thought, oh, and he means wine, I thought he just meant types of wine. Well, that would be perfect, wouldn't it? Because then when we sat down to talk about this, we could clarify that. And that's exactly what users and designers do together. They get a common agreement on what that means before they move forward. And that's going to dictate the type of database we get. All right, so that's just fine. But the way I'm thinking of it is that wine stores each and every individual bottle of wine as a separate entity. This is called the entity relationship diagram. If you're writing an exam and I ask you to do an ERD, I mean something that straightforward, the rectangles and the relationships between them. All right. Once we have it, though, we can go a step further. And to go a step further, I'm going to say, well, what fields or what attributes would be in each of these? So it's almost like I have a little drop-down arrow. I click and it opens up and I say, oh, here's all my different fields. Well, if I do that, I'm into something called a table map. All right. And it looks a little bit like this. So I've taken wine and supplier and I've expanded them out. All right. Let's look at supplier first, maybe on the right in blue here. I have a supplier ID. That's actually going to be my primary key because it's going to be unique for every supplier. That's my key field. I have the company, the rep, the address, the city, postal code, and telephone number. You may think of other things you want to keep in there, and we could maybe add a few to that list. That's okay. But that's good enough for now. So that's supplier. On the wine side, I'm going to have a primary key for my wine as well. I'll call it the wine ID. Maybe it's just a number I make up. That's fine. Most database systems, including Access, have a way to automatically make up a number for IDs if you want. It's called auto number. What else do I store about the wine? Well, I've got the name of the wine, the type, the color, and the year bottled. Maybe that's enough information for me. Oh, but I wanted to know who supplied the wine. How could I do that? Well, I'm going to cross-reference and put in the supplier ID. Now that's nothing to do with wine other than it's a cross-reference over to the supplier table. Notice everything else in the wine table is wine-related info. Everything in the supplier table is supplier info. I do use that one field, though, as a cross-reference. When we do that, we call that a foreign key because it's a foreigner from another place, but it's going to help us make that cross-reference or that link. Let's put the relationship in then. It's going to go from the supplier ID in one table to the supplier ID in the other. So now I get a little more specific than I had previously in my entity relationship diagram. I can be more clear now. And I said in there, there's a relationship. Well, each supplier could supply many bottles of wine, but each bottle of wine comes from one supplier. So now I've completed it and I've put my relationships in just like I had before with the many to one side of things in there. All right. There's a few things to notice, I suppose. The one side of a relationship will always hook up to a primary key. The many side hooks up to a foreign key. All right. Because let's think about it. If I've got 3 bottles of wine, I want them all to have the same supplier. It's going to get repeated over and over again, isn't it? The same supplier ID. All right. So it can be duplicated in the wine table, but it could never be duplicated in the supplier table. All right. So it's only in there once, whereas it can be in multiple times in the wine table. All right. So that's the basics of setting up relationships for you. All right. Once we've gone this far, we might enter into something that we call normalization. That's the process of coming up with a good design. And I give you a little list here of things to watch for. Every table should only deal with a single concept. And we'd had that. We had a table for wine and we had a table for supplier. We didn't try to mix the two things together, so that's fine. We don't want to duplicate data, so I wouldn't put the supplier's phone number in with every bottle because I'd have to retype it over and over again. As long as I have that cross-reference link, that's all I need. All right. Now we can't have any many-to-many relationships either. I'll talk about that in just a minute because most database packages don't know how to deal with that. So we'll learn a trick for getting rid of those. We don't store calculated data. All right. So I may not store the selling price of a product after tax. I'll store the price before tax, and I'll have the tax rate somewhere else, and then I'll just calculate on the fly. That way, if we change the tax rate, I only have to change it in that one other place, and then the calculation will still work correctly, rather than having to update every single record as we go. All right? And then finally, store data into their smallest components or pieces. So instead of just saying name, break it apart into first name, last name, maybe even middle name as well. Instead of saying address, have the street address, the city, the postal code, the province, the country, that sort of thing. Break it apart because later on that's going to make it easier to search and sort and do queries and all sorts of things like that. Okay. What about those many-to-many relationships? How do we deal with those? Well, we're going to replace each many-to-many relationship with two one-to-many relationships. All right, and we're going to introduce an extra entity called a join table. Luckily, the join table is just something obvious we might think of in real life anyway. So let's just imagine we had a customer table. And over here, we have a product table or entity. Well, we do know customers order products, don't they? Customer can order many things from us, and each type of product could be ordered many times. So if my product list is things like pens, pencils, paper, well, that could get ordered by many people over time. All right, so this is a little different than the last example. Product here is really just the type of product, not every individual inventory item. So that's fine. So I have many to many, but that's no good. I just said we can't do those. Instead, we have to add in a new table in the middle to connect these two things instead. What would that new table be? Well, what's the event that connects a customer and a product together? Probably the sale or the order. You could decide the sale or the order, and that would connect them, wouldn't it? Now, each product can get sold multiple times, but each sale is only for one product. Each customer can have multiple sales orders, but each sale just talks about one customer. So now I've replaced my original relationship here with a new one on the bottom. All right, so I can now go through and eliminate that one or delete it. All right, good. So now I've got customer related to product through the sales event, and I have two one-to-many relationships. By the way, the sales table will have two foreign keys in it, won't it? One from the customer side and one from the product side. It'll also have its own primary key, but there'll be two foreign keys, and that'll help connect things together. All right, so that's how we can eliminate those many-to-many relationships. Oh, by the way, what if you said, look, each sale could actually have multiple products? What if that was an M instead of a 1? Well, I would just do the same thing again. I would come up with maybe products sold as a table and connect those two, and again, set it up with one-to-many. I could keep going, couldn't I? And keep working on that. Let's not overly complicate life for now, but you can see that's how we could just keep repeating the process. All right. Data dictionaries, I've mentioned those. I haven't talked too much about them yet, but it's kind of like we took the wine table and expanded it out to the right. So I could tell you more information about each of those entities, or attributes, or each of those fields. All right. So let's look at wine ID. I just said it's an auto number. I'm going to let the database make up a new and a unique number for every bottle of wine, and it's going to be my primary key. The next one we had was supplier ID. We'd filled that in, remember, as our foreign key. That was a foreign key from supplier. So I put that in there. What kind of field type is that? Well, let's imagine it was auto number over in the supplier field so that my database made up a new number for every supplier. That would mean that it's just going to be a number here because I'm only referring to it. I don't want to make up a new one. I just want to refer to that supplier number that's already been made up somewhere else. So it'll be a number. And then I had the name of the wine. I'm going to say that's a text box that gives me room to type in 30 characters. The type, another text box that lets me type in 10 characters. The color, ooh, here I put some properties. It has to be either red, white, blush, or rosé. Maybe I could even make that a drop-down list. So that's something we could think about when we came to building our database. And then finally, the date, the year that it was bottled, but I only want the year. And so I just made little notes in there. That's going to help the programmer as well when they get to building our system. So that's a quick overview of database design. We typically want to do all three of those. The entity relationship diagram, then we expand that out into the table map, get everything sorted out there, and then we expand each of the tables in the table map into a data dictionary, one per entity, right? One per table. So we'll end up with multiple data dictionaries as well. All right. Then you've got a good database design. Now I've put a little database design guide in D2L for you. It's called Rob's Handy Dandy Super Duper Quick and Easy Guide to Database Design or something like that. And you can download that and use that as you work through our exercise. All right, well that's it for this portion. I'd like you to now go and do some reading in Chapter 5 and through the D2L content I've posted, including all the extra stuff, and then work on Exercise 5. And you may find that's enough for this week. That's what's due this week. We're going to carry on with more Chapter 5 next week, so you could do the chapter simulation then, or you could do it this week too if you have time, as well as a quiz. So for now, I would suggest make sure you get through these two, and these ones down here are kind of optional, but they'll have to be done by the end of next week. All right.